you can be asked to write a pseudocode, and that pseudocode, they are data types. You can be given a program, and then you are asked to write a pseudocode using that program. So that's why we are looking at the data types. All right. Now, what is a data type? When you talk about data types, we say they are keywords. Actually, this is not the definition. I've just realized this is not the definition for the data type, but there are those keywords that help the computer or the compiler to understand the type of the data type that you are using, or the type of data that you are storing in a memory. Like, for example, if you store numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, if that memory location, you have to give it a data type, which mostly we use integer and such. So data type, actually, it can just display for you from the internet a definition for data type. Sorry. So for data type, we can have is a simply type, is an attribute. This is now the definition. Let me just copy it. There it is. Okay. So it's an attribute. This is the so it's attribute of data which tells the compiler or interpreter how the programmer intends to use data. That is the definition of a data type. So we're going to look at the different types of data types. In this, I was just explaining, like, for example, if you are to store letters like names of people, Alan, Joseph, John, you'll have to define the data type of such data, which mostly you use strings. We use a data type called strings. Yeah. And one thing you need to understand about the data type, you cannot use a data type like I've said. When you want to store numbers 1, 2, 3, 4, you use integer. If you want to store letters or names of people, you use strings. You cannot use an integer data type to store letters. That one will generate an error. Let me just demonstrate what I mean by that. You cannot do something like this. You cannot say strings names, and then you say is equals to 5. So this one is, you have declared, that's a minute. There it is. So this is an error basically, because whenever you declare something as a string, it simply means that this memory location you've created here called names is supposed to store letters like names of people. But now when you assign it such, it's going to be an error. Not unless you do something like this. You do something like you open some 2 double quotes. Then from there, this one, the error will go, because the computer will, the compiler will see this 5 as a letter, as part of the alphabet. But if it was just 5, then it will generate an error. It's because 5 cannot be stored in a memory location that is supposed to store letters. So this is just, let me show you another example. Like, for example, if I say int names, and then these int names here, this is correct, this is incorrect. Why? Because these names, this memory location called names, is supposed to store numbers, whole numbers. That is, numbers which don't have a fraction part, or they don't have decimal points. So if I declare it like this, and then I put my 5 with quotes, this one would be an error because this 5 is not a number. This 5 is a letter, interpreted as a letter by the compiler. So what you do, you can just remove that, and then from there, so if you say something like this, int names is equals to 5, this is correct. Why? Because this memory location is supposed to store numbers, and that is correct. If, for example, I come and store something like this, 5.5, something 5.6. So int names is equals to 5.6. So this one would also be an error because this memory location called names is supposed to store numbers of whole numbers. That is, integer is for whole numbers. This data type is for whole numbers. Whole numbers. Those numbers are not, which are not supposed to have decimal. So if you store something like this, the compiler will generate another error, and it will inform you that you lose some data. When you're running this program, some data will not be displayed. Like, for example, this 6 will be discarded. And therefore, you find that if you are doing calculations, you'll not be able to get the right answer because some numbers will be. So in this case, we use another data type. For the data type that has got a decimal point, we use another one which is called float. Of course, we're going to talk about that one as we continue. So for this one, we use a data type called float. The float data type is used to store decimal numbers with a fraction or numbers. Is a data type that is used to declare memory location that will store numbers with a decimal point. So that is just an introduction. So I usually give this example that when you have a computer room, an empty computer room. So that is like an example of a memory, a computer memory that does not have anything stored in it. And then you say in a particular corner in that computer room, I'll store data which are whole numbers, that corner. So you have to give that corner a name. Like you say, I'm going to give it a variable name, which is A. And then for the data type, because these are whole numbers, I'll store whole numbers in that corner. I'm going to give it a data type like int. So you're going to say int A, and then you can say A is equals to 5. Okay. You've just assigned. So like this, we have a particular corner in a class. Just show you this one here. So this is a class, and now you want to store some data in this particular corner. So you're going to create a memory location here, and then of course you have to give it a name. So you can give it a name A. So I've given it an A. That is the name of that corner. But then because there is a particular type of data that I want to use, there are some things that I need to. Okay, this one actually we can put it outside. Let's put it outside. This A. It can be somewhere here, and then we say A. So what we are saying. So this is a corner in a class, and then you've called this corner A. You have given it a variable name called A. And then you want to store some data inside this A, like you want to store number 5. So what you do, you're going to type number 5 there. But now you still have to do something else. You have to declare, you have to give this A a data type, this memory location. You have to give it a data type and say, this memory location is supposed to store a whole number called 5. So that's why you give it a data type like int. So you just come and say int A, and then you terminate. So what you are saying is int A, And so this one, you're saying that this memory location called A is supposed to store whole numbers. This integer represents whole numbers. So every time now, once you do this, every time you'll be calling this memory location called A in the program, this program will be generating number 5. Every time I call, hey, come here, he would be giving me number 5 because that is what that memory location, hiyo ndio kitu imewekwa kwa hiyo memory location. That's what we call, that's a data type. If you want to store some other data type here, you just do the same, like 5.5. So you can have another data type here. And then we say you want to store numbers with a decimal point like this. So this one you have to give it a variable name first of all. So just do this. You call it B, but then you also have to give it a data type. You say because this location here is this particular location is supposed to store numbers with a decimal point. You're going to give it a data type called float. So there it is. So in this computer, in this memory, we have assigned two variables. One is called B. One memory location we have given it the name B, and the other memory location is called A. Then we've said in A we're storing whole numbers, so we're going to give it a data type called int, and this memory location called B, we're going to store numbers with a decimal point. So you're going to assign it a data type called float, and that's how we declare. Now let's look at these the various data types which are usually in this. All right. Okay, now let's look at one. One of the data type is called integer. Integer are numeric data items which are either positive or negative, including 0. So even a 0 is an integer number. If, for example, you have 1, this is an integer number. 488, this is an integer number. Negative 22. Let's say your program will be storing numbers with negatives. You're going to declare that data type as integer also. That memory location, you're going to call it, give it a data type integer. Then if you have this 0, this is also an integer of integer data type. 456 is of integer data type. Then you can say some programming languages put restrictions on magnitude of integers which may be used in program instructions. These restrictions are usually dependent on the size of the memory location of the computer which the language may run. So of course, when you look at this category of integer, there are some computers. Of course, when you declare something as integer, there is a particular size of memory that memory location will be given. Like you may find when you declare a memory location of to be of type integer, that memory location will be given will store a maximum of like eight bytes. Okay, of course we'll look at that one later. But first of all, I just wanted to introduce you to the concept of the different data types that are there in programming. This one integer stores whole numbers. Then also we have this one. This is, you'll find this one in Pascal, I think. The real numbers is also a data type. When you find these real numbers or real number data type, there are two types of real numbers. One is a fixed point, and the other one, my screen is so bright. Let me reduce the brightness. Yeah, I think that is okay. Now we are looking at this one, the real numbers. So we see that these are fixed. We have two types of real numbers, fixed point and floating points. So these ones are the ones that store numbers with a fraction part. Like for example, the floating point data type. We say floating point data items are numbers which are held as binary fraction by the computer. And we have examples here. Okay. Don't worry about these concepts here. Will be, but what I want you to understand is that they store numbers with a decimal point. Also, in the floating point, if I use a whole number like this one, you see this one is a whole number. This one does not have a decimal point. This one is no problem with the floating point data type. It will not generate an error. It will not generate an error. It will just proceed. I think you guys are doing computer mathematics. Have you looked at this one, the mantissa and exponent? This is in computer mathematics. You're supposed to be covering it. If you have not covered exponent, mantissa, and such, computer mathematics. So for us, we just need to understand the data types. We have 12.3. This is a number with a floating point, and of course, this one is okay. So this one is also okay, even though it's a whole number. This one is also okay. So floating point representation of data is used to overcome the restriction placed on the numbers by the size of the computer memory. So most of the times, when you are writing programs, most people prefer using the floating type because you find people may want to put some numbers with decimal points, and if your program, if you used, like for example, integer data type, the integer data type cannot allow you to use numbers which have a decimal point. So you find that in most programs or most projects that are down out here, most people prefer using this data type. Yes. So also you have another data type called character. These are data type that is also referred to as a string. And a string data type is mostly used in Java, in such programs, Java and things like Ruby and Python. But for C, in the C program, we'll be using character data type. So, and mostly character, they store one character at a time. Like character, you can store B, you can store C, you can store D, like that. So they store one letter at a time per time. But if you want to write a whole sentence like this, Happy New Year, there's a way you declare it. You declare your, of course, we'll be looking at this one. Yeah, but what I need you to understand is that characters, they store letters or alphabet or symbols. I know, so we'll pick it from there next time. But that is the concept. Then also we have the Boolean data type. These ones are used as status indicators and may contain only one of two possible values. That is either true or false. Yeah, so Boolean data types are used as status indicators and may contain only one of two possible values, that is true or false. So when you talk about these Boolean data types, mostly we use them when you're doing logical operations. Yeah, logical operations. And of course, you can also write programs using. So most of these ones, when you declare, for example, something as, let me show you what we mean by this. Boolean. Okay. Then you say A. Then you'd assign this one. This A can only hold two values. True. Okay. Let's say we declared two types, and another one there we declare another memory location called Boolean B. So then true B is equals to false. Okay. Then you say printf b. If there's something like that, then printf a. This is another, just an example I'm giving you as to what you are likely to encounter in the future. So this one, I have two Boolean data types, two variables of Boolean data type. That is A and B. So these variables called A and B can only store two types of data, two values. That is either true and false. You cannot declare something as a Boolean and then you come and say A is equals to 5. And then you say B is equals to 6. That one will be a problem, or will be an error. So if I printed B, B would be false. And then if I printed F, the output will be, if I printed A, the output will be true. So that is what we mean by this. So Boolean data type, they hold either true or false. Okay. Of course. So if I can put some output, this program, when you run it, is going to give you false, and also it will give you true. That is the output of the program. Either, so when you run it, it's going to give you false true. And of course, this is true than E. So that is how we use the Boolean data types. They store either true or false. So I hope you have understood that. Let's look at something else. Those are the major data types that you'll actually find in programming. Data items. We say there are two methods of using data items. We have something we call constant, but we will look at it later on in the course. Okay. Yeah, we'll be looking at it later on in the course. But for the guys who are in the town campus, we had already given a definition for constant. And if you remember, we say that constant are those numbers that do not change during program execution. They remain constant. They don't change. They are always the same. The memory location of those variables do not change, or we can say the values stored in those memory locations do not change during program execution. Okay, but now for that one, we'll be looking at it later on. So a constant is just a value stored in a memory location, but that value does not change during program execution. We'll be looking at that one later on as we continue. Then we have this term here. I've already used it. This one, variable and variable names. So what is a variable? A variable. What is a variable? It's a symbolic name assigned to a data item by the programmer. A variable is a symbolic name. A symbolic name assigned to a data item by a programmer. Okay, let's go back and look at this example here. The one that I gave you for a class, a blank or a memory, a blank memory, and then you realize you want to store some character in this corner, some values in this corner, and other values in this. So first of all, you have to give those corners. You have to give those corners names, and those names are what we are calling the variable names. Like for example, B is a variable name, and also A is a variable name. Variable names. They are those names that you actually assign to memory locations. Like just a minute. A variable is a symbolic name assigned to a data item by the programmer. They are those symbolic names. At any particular time, a variable will stand for one particular data called the value of a variable. So like, what can we say? So every time, of course, you declare a variable, you have to store values in it. Yeah. And so like, why was I introducing you to the concept of data types? It's because I'll be showing you how to write programs, how to write pseudocodes that have got variables in them. Because at times, when you go to the exam, or maybe when you're doing your own business, you may be given a program, and you know program must have a declaration, it must have those variables, must have. So how do you write such pseudocodes? That's why I've introduced you to the concept of the different data types that we usually have in programming. So assignment operation, this is another point now. We are done with the data types and variables. I hope you've understood what we mean by variables and variable names. So a variable, you have said, is a name given by a programmer to certain memory location. And of course, those memory locations change during. They are not like the constant. The constant, the value stored in a constant variable, do not change. But for variables, the values that are stored inside the variables change during the program execution. Okay, so this one we have in Pascal. This is how we declare a variable. We create a variable and then we put a full colon. Let me zoom in. So this is how you declare in Pascal. You say variable full colon and then you assign. Okay. And then for the C and C++ and Java, you say variable, like you can say int b is equals to 6. Okay. For Pascal, you say int b full colon is equals to 6. Of course, we'll be looking at Pascal as we continue because you guys are supposed to do both C and Pascal. We'll be looking at that one as we proceed. Now, the assignment operation is used to assign a name to a variable, to a value. The assignment operation is used to assign a name to a value. Thus, whenever you need to keep track of the value that is needed later. So when you say, for example, count is equals to 0, in programming, this is what is called as initializing. Initialize. What is to initialize? Is to set a variable to a given, is to set. Unajua kuset, nimeset hii number itakuwa, hii variable itakuwa inaanzia from 0. So to initialize, when you hear people in programming talk about I have initialized my variable, what you are saying, I have set this variable to be starting at a certain place. When you hear something or people talk about like increment and decrement, increment in programming is when you want to add a number by maybe 1, or you want to add a value to a variable by 2, or decrement is subtraction. Is the opposite of increment. So increment is when you want to increase a number by maybe 1. Like for example, here we've got a variable called count, and then we have said is equals to count plus 1. So when you're running this program here, count will be, let's say for example, count was 0. We assign this count is equals to 0. When you run this program and it's like this, count is equals to count plus 1. So the output of count, let's say for example, you add a printf right after this printf, then you say count. The value of count will be 1 because count was 0. So you're going to do 0 plus 1, and then you find the value of count is 1. So it's incrementing. Incrementing is when you add a value. When you add a value to, you are breaking. Somebody is saying I'm breaking. Who else? Can you hear me now, Esther? Am I clear as I continue with the class? Okay. So when you say to initialize, I've already said that to initialize is when you give, when you set a variable to a given value. Unasema itakuwa inaanzia from 6. You can say count is equals to 6. So what you're saying, when this program will run, it will be starting from 6 going forward. That is to initialize. To increment and decrement is either to add a value. Increment is to add a value or value. To decrement is to subtract a value from a variable. Okay. Accumulate values. That one, the sum is equals to sum plus item. That one, do we need to have that? Accumulate values. Accumulate values. Okay, these accumulated values, we have it somewhere. This one I have not, is not there in this course, I think. The accumulated values, it's not there. So this one, I think we just leave it for now. We don't have it actually anywhere in C. I've not seen it in C. The accumulate values. Let me check from the internet whether they have something to say about it. So accumulate values. In C. You see, it's not, they're actually saying C++. I don't know whether they have it in C. Let's wait and see. C programming. No, it's not. C version of accumulate. Okay, I don't know whether they have that. C version of accumulate. Okay, let's see. Okay, this one is not there in C. Aiko. We mostly have it in C++. When you talk about C++, actually the book that I was using to make these notes is not necessarily a C textbook. It's a combination of different programming languages, because we usually say that programming languages are related. They are all related. That simply means if you do C, you can easily understand other programming languages like C++ and Akina Java and such other Ruby, Akina Django and such. It will be very easy for you. Okay, so now I think this one is not there in this one. Capture the result of the computation. Y is equals to 3 times x plus 4. Of course, this one mathematically you can interpret it. Also, this one mathematically you can interpret it. So also this one you cannot. So have two values. T is equals to x. So you have assigned the value of x to t, and then you say x is equals to y. So you have assigned the value of x to. So you're saying x will now have y, and then you say y is equals to t. So what will happen in this program? Let's try and interpret it practically. Let's interpret this one using practical examples. Let's say, for example, we say int x, y, z. Int y, x, y, and then we put a z. Then we say t, x, we are not going to assign anything. We say y is equals to 5. And then z, are we going to assign? Do we have z? Okay, we have t, we have how many variables? T, x. we only have two, t and x and y also. Those are the variables we have. We have t, we have x, and also we have y. Those are the ones that we're going to declare. I hope it's understandable. Let me zoom in. So in this portion, we have three variables. That is t. We also have. Let me zoom in. Right. So we have three variables: t, x, and y. And then we say we can actually assign all of them. We say t. We say t is equals to 5, and then we say x is equals to 6, and y is equals to 7. Now we're going to swap. What is to swap? Is to exchange. When you find that word somewhere in programming or any other place, when you hear people talking about swapping, swapping girlfriends, swapping boyfriends, okay, swapping classes, swapping matatus, like I did today in the morning, swapping, all those swapping. When you hear of that, is to exchange, is an exchange. Eh? So we say t is equals to, in this one, t is equals to x. So what will happen in this program? T is equals to x. So the value of t will change to 6. And then x is equals to y. So now the value of x will now change to 7. And then you say y is equals to t. So the value of y will be 5. So if you are to run this program, the value of t will be what? If you are not to print out, you come and say, let's try and do something constructive. We try and output these values. Print f. I'm not writing it the way it's supposed to be written. I'm just writing it in a short form. We say t x y. So what will be the output for this from using that example of swapping? So the output will be for t will be what? The t will be, we have said t is equals to x, so the value of t will be 6. And then for x we have said x is equals to y, so the value of x will be 7, and then for y will be 5. So let me zoom in so that you can see. So we are swapping, we are in this point here for swapping two values, or actually swapping. So we have said here we have int t, x, and y. We have declared them. Then we say t is equals to 5, x we have initialized it, or we have initialized it to 6, y we have initialized it, or we have assigned it. Initializing and assigning is the same word. You have assigned 7 to y, or you have stored 7 in y, in a memory location called y. Then you say, you put this statement. Let me try. Is it possible? Let me see whether it's possible. Just give me time. Try and crop. Crop. So this, oh my, sorry. I hope this one is clear. So here we have three variables and ty x and y. Then we have assigned that one like that. Then you say this one here t is equals to, actually this word is not supposed to be there. You can, this one, the swap to letters is just a concept that we're introducing. That we are just saying that it's like a comment for this. You know what a comment is? I think I talked about comment. We can put a comment. Actually after this comment zinakujanga hii side ingine. It's only that acha niitoe kwanza ndio msiseme niliwaambia mwandike hiyo program in the future. Acha niitoe hii swap. Let me remove it completely because I know some students do have a photographic memory. So what they do, what you teach in class, they like capture, even if it's a mistake, they will like take the photo of that, and then that one will stick in their minds forever. That's what I'm avoiding. So we are in the concept of swapping. Of course, even these brackets are not also there. I can also get rid of them because, of course, okay, acha zikae tu for now because we are not writing a real program. Slideshow. So here we have an extract of a program. So if you say this one, t is equals to x. So currently t was set to 5, but now you are saying when memory location unaitwa t, chukua ile value iko kwa x, so itakuwa ni 6. Then x is equals to y. So you are saying new memory location called x. Pick the value that was in y. So it will be given 7. And then y, you say new memory location which is called y. Pick whatever is stored in t. So it's going to pick number 5. So when you print out or when you run the program, the output will be 6. The value of t is 6. The value of x is 7. And the value of y is equals to 5. So that is swapping. It's just an example of swapping. Tuendelee na hii example. Tuendelee na, I hope those concepts are clear. Now, of course, we've already talked about this one, the pseudocode. We don't have to really go deep into it. It's just like an overview of what we have already discussed. Pseudocode is a generic way of describing algorithm without use of any specific programming language syntax. So of course, we have given it that name pseudo. I said is a simply means not real. It cannot be executed on that code cannot be executed on a computer programming language. Yeah. They borrow their syntax from C or Fortran or from Pascal. Okay. So like for example, if you know how to write a Pascal program, and then you see when you see how we write pseudocodes and how we write programs in Pascal, you may actually think they are one and the same because Pascal they are somehow similar. They are somehow similar. Let me give you a program that is written in Pascal so that you stop talking, you stop speaking of things that you don't know. You don't know. So introduction to Pascal. A minute, my computer is not responding. So introduction to Pascal. Let's just look at one of the programs. Program structure. No, kama hii. I hope I can just copy it. Huh? Yeah, that's what happens with this. Just give me a minute to print screen for you so that you see what we mean. Eh? These are a program written in Pascal. We'll be looking at Pascal in in-depth, in a more in-depth way. So we say that pseudocode, they borrow their syntax from programming languages like C, Lisp, Fortran, but also they borrow from Pascal. So like here we have a Pascal program. You see, it's written program hello world. So in this one, we don't use a preprocessor directive like hash include standard input output.h. Wale wamefanya hizo program. Wanajua how we usually begin in writing a C program. A C program we begin with hash include standard input output.h. For Pascal, we start by program hello world. Then uses control. This is CRT simply means control. Then here the main program block starts. So this is a comment. This is a comment just telling us or explaining to us that this is where our program will start. So as you can see, it's somehow similar. It's similar to what? To the pseudocode in that we start with the begin and also we have got the end. Okay. So what will happen if you run this program, you just see the statement hello world. We'll be looking at it later on. As you can see, programs are changing. As in the next program has changed. The calendars actually they have been affected. That's why even your results have delayed. And also, I'm very sure the exam may not take place because there are some schools which are not in school. Of course, they don't have this technology we are using. Most schools they are not in session. So of course, you find with that interruption that the calendar will change, especially for exam and such things. So what I'm saying with that is that we have a long time. We have at least some allowance to explore some more things in this programming. We will explore many things. Yeah. So including this Pascal, we'll look at it in a very in-depth way. So that's how you can see the structure is the same. So like for example, we said begin some you find some books they actually when you're writing a pseudocode, they will start with begin and then they end with end. Okay. Yeah. So of course, I have shown you this one. You already understand what we mean by sequence structure. If you are to write a pseudocode using a sequence structure, and of course, we have said a sequence is where instructions execute one after the other. Like for example, if you have a program that is finding sum of two numbers, actually this is not correct because first of all, you're supposed to first get the two numbers, and then after you get the two numbers, you get the sum, and then after you get the sum, you get the average, and then you output the average and also the sum. So this is not complete, but it's just an illustration of how we write a sequence structure, or we write a pseudocode using a sequence structure. Then of course we have the flowchart already. I realized I did not give you the advantages and disadvantages of flowchart, but it's okay. So this one is a flowchart representing this particular pseudocode that we've looked at here. So the first one is to get some, of course. How do you get some? Hii si correct, hata kidogo. Because how do you get some in an input? Using an input symbol. You see this one is not correct. It's supposed to be a process. Because sums in calculation. So first of all, you're supposed to input numbers, number one and number two. Then after that one, you use a process symbol to get the sum, and then after that one, another process symbol to find the average. This one is correct. So if I was marking this guy's exam, whoever wrote this book, ningemwekea tick hapo, nimwekee wrong hapo, nimwekee tick hapo, and of course now aja output the average. So hii flowchart si complete, it's not complete. So ameanguka, anaweza pata max. If it was out of 5, anaweza pata like three marks. So now, this is an example of a pseudocode using now variables. With what we have done with the introduction of variables or the different types of data types, you'll be able to understand this concept now. Now, this pseudocode is required to input how many numbers? 3 numbers from the keyboard and output the result. So it's supposed to actually the question is not complete. But what you're supposed to do, you're supposed to accept 3 numbers from the keyboard, and then we find the sum of the 3 numbers, and then from there we print the sum. So in a real program, like let's say it's a C program, this is what you'd write. Let's write using C programming. Okay. My computer is not responding. Oh, bad. Let me show you what you usually have. We usually have in there. Of course, there are some guys who know these things, especially, and most of you may be having a clue. So we begin with hash include, then stdio.h. This is how we write a C program, and then we say int main. We've created a main function called int main, and of course it has 2 parentheses, and then you open a curly brace. Then you're going to say int number one. Of course, you don't have space. Those are rules. When you're creating a variable name, you do not give them space, like number 1, number 2 with a space, number 3 also. Now this one is a long program. A long, like for example, you have to print F, long, accept 3 numbers. So you're going to say scan F. And F is when you want, of course, we'll talk about this one. If you have not done this concept, don't worry about it. We're going to look at it step by step. It's only that now I want you to understand what usually happens. Okay, so here we have a C program. I hope it's clear to everybody. So this is a C program. Hii kitu haitoshei kwa screen. I'm trying to fit it on the screen. We can go back to the way it was previously. Okay, so here it is. So every time you're writing a program, you first begin by, of course, you begin by declaring. We're going to start from this particular point. This one, int number 1, int number 2, int number 3. These are the variables that we'll be using. We'll be using 3 variables. And then printf is actually, this one is a message that will show. This is what will be displayed on the screen when you run this program. So it will be accept 3 numbers. Okay, then you enter your 3 numbers: 5, press enter; 6, press enter; 7, press enter. Then once you have added those, now you've entered those numbers, sum will be number 1 plus number 2 plus number 3. It will store the number that you've entered, and then after that one, this statement here, print f sum is equals to, this one will be used to display the sum. So of course also kuna kitu ingine tumesahau hapa, which is called sum, because sum also is supposed to be part, is a variable. Ilikuwa nimeisahau. Yeah, so it's supposed to be part of the variables. Okay, so now let's interpret this program into an equivalent pseudocode. So you're going to start by the pseudocode, of course, has to have a definite start, si ndio? Utakuja hapa juu useme start. Hii sasa kwa hii pseudocode utaanzia na start, and then you have to say use variables. These variables, use variables, full colon, sum, which is our first one, our first variable. Number 1, you can see they are different. The pseudocode and the way we write a pseudocode and the way we write program are different. But this is now a description of what is happening here. So sum, comma, number 1, number 2, number 3, they are of type integer. So as you can see, we declare them as to be of data type integer, and then accept number 1. Okay, so we said the program will accept number 1 and then accept number 2, and then, or you can also have, because we have this one here, printf accept 3 number. Okay, of course it's okay. So accept numbers 1, 2, number 1, number 2, number 3. Then of course this one, in a pseudocode you don't terminate like the way we are terminating. Terminating ni kuweka hizi semicolon huku mwisho, and of course hapa nimeweka comma, which is an error. Hii ni error kubwa sana, inaitwa syntax error. Comma hapo, na nimeona pia hapa nimekosea. Those are just printing mistakes which you'll also find when you're writing programs. So we have accepted 3 numbers. Then after that one, you're just going to say sum. After include hii part ya scanf, because already we have included hapa kwa accept. Hii accept, so hautasema ati scanf, hapana. So for you just go to sum. You skip to sum. You say sum number 1 plus number 2 plus number 3 plus number 4, and then of course print sum, and then end program. With that, let me ask whether you are getting. Let me go back to the class and ask you whether you are getting. Okay, are we together up to that point? If you're understanding, just say yes. If you're not understanding, just post a question in the comment section, because Holshon anasema yes, Cynthia Malo anasema ndio. How many are we in total? Let me check how many we are in total. We are 7, a total of 7 guys. 1, 2, 3, 4, 5, 6. We are 7 guys. 1, 2, 3, 4, 5, 6, 7. Only 7. We are supposed to be like, how many? Town campus only we had like over 11 guys. So kuna watu join bado. So the revamp anasema yes. Haya. Sawa sawa. Okay, thank you. You can see that most of you we are together. It's good. PowerShell. You are breaking. Oh. Haya, sawa sawa. Hiyo tulimalizana nayo. So I think up to that point we are okay. Let's go to another example. Another example here. The following pseudocode describes an algorithm that will accept two numbers from the keyboard and calculate the sum and product, displaying the answer on the monitor. So this is very simple. Also, first of all, you begin with start, okay, and then you say use variables. Use is in kitabu. Don't forget. That's why they are not including there. They are leaving out something. So for you as a student, you have to start with a start. Don't forget that. And then use variable sum, of course. Also, we'll be using product because, as you can see, when you are writing a program, the first thing you do, you have to identify the number of variables that you're going to use in this program. In our program here, we will accept two numbers. So those ones already are two variables, number 1 and number 2. And then from the keyboard and calculate sum and product. So we have another variable called sum, and also we have another variable called product. So when you are declaring, you're going to say use variable sum, product, number 1 and number 2. Of type, it can be type integer or whichever data type you'll be using. Display, input two numbers. Okay, this is if you are display input two numbers. Like for example, in this one, we didn't have that display accept two numbers. Tulisema to accept. So ingekuwa you have also when it was already written this one. This is actually a print screen. Okay, just a minute. So display, this is the printf statement. Unaweza interpret useme display input two numbers, then after that you're going to accept. This part of accepting number 1 and number 2 is what we have the scanf. The scanf, instead of saying scanf number 1 and number 2, you're going to write accept number 1 and number 2. And then of course after you have accepted number 1 and number 2, you're going to enter or write the sum number 1 plus number 2. Then you print the sum is sum. Of course, this one is the way it's written. You can even say the sum is, can you say print without using these quotes, and this comma here. Si lazima utumie. Unaweza sema tu print the sum. And then product is equal to number 1 times number 2. Then print the product is product. And then of course you end the program. So that is the pseudocode. This is when you're given a program, a full program now, and then you are told to interpret that program into an equivalent pseudocode. Or also at times you can be given such a program, the one that I have here, this one, and then you're told to write a flowchart, to draw a flowchart of the same. Of course, I know you guys can do that. Actually, you'll be doing that before the end of the lesson. Okay, so hizi tulikuwa tumeangalia mambo ya drawing of writing what is a decision structure. I think we had looked at all this. Logical operations. Kuna vitu tulikuwa tumesoma hapa, lakini design an algorithm and corresponding flowchart for finding sum. Niangalie kama kuna kitu tulikuwa tumesoma. Okay, do this. I want you to write this. I want you to write a flowchart for this program here. Acha nimwekee kwa nini yake. let me put this one in its own. I want you to draw a flow chart using whichever method. You can use your Microsoft Word, or you can write in your book. Draw a flow chart for this program here. Interpret this program using a flow chart. And then from there, we see whether we are in the same page. So draw a flow chart for this. In the next how many minutes? Let's see what time it is. Right now is 10:36. So in the next like 10 minutes, so 10:46, we should be done. Yeah, so let's do this. I'm just going to do something here, something small. Then share. I think now you can see the screen. So you're interpreting this program into an equivalent, into an equivalent flowchart.
All right. Okay, so nene huyu anaitwa Cynthia. Cynthia amechora na iko sawa. It's okay. Yours is correct. I know the rest will copy. Ama ni delete ndio wasiseme iko ni sawa. So the rest draw, tick. Okay, what about the rest? Ina Janet Wangari, Esther, and Ian, Paul, Edwin. with no other students submitting their work, we're going to come to the end of the lesson. I think I've seen several who have shared. We have Cynthia, Paula, then we have Janet Wangari, and then Esther and Joseph. Tuangalie sasa tuone. Cynthia hapo iko sawa. Janet Wangari. Tuangalia Janet iko aje. Tuone kama tutamtoa makosa ama tutapatia tick. So Janet, you've started. Then after you started, you inputted 1, 2, 3 numbers, and then after that one you found the sum. Okay, then displayed. What was the question about? It was that. So yours is correct. Yours is correct. Janet, yours is correct. Let me see about Esther. So if I put a like is a tick. If I put a third, that's a wrong. But I'm not going to use anything for the wrong or the incorrect ones. So let's see who else here. This is Esther. Esther is start, accept, and some. Accept some? No, Esther, you're not supposed to accept some. You're supposed to accept number 1, number 2, and number 3. Then of course from there, okay. For this one, for flowchart, you don't show the declaration. Okay, or unyoshangi venye we declare that you declared int, you just go directly to input. Unasema zile vitu na input alafu una find the calculation. So I understand where you're coming from, but okay, for the sum it's not supposed to be here, but it's supposed to have number 1, number 2, number 3. Okay, get sum, get average. Always, let me see whether we are getting the average. We didn't have the average in the program, so hii average haiko inafaa kuwa get average sum. So hii iko inafaa kukua. Haya, so kuna hizo vitu mbili. What about somebody else here called a minute? It's called Joseph Kinuthia. Start, accept 3 numbers, correct. Get the sum, print the sum. That is correct, Mr. Then we have Ian. Ian is here. Then start, input number 1. Okay, you would have said enter number 1, number 2 instead of input. Enter. Okay, so this one is clear. And input number 1, number 2, number 3, that is correct. Then sum is equals to, this is which symbol? Which symbol is this one that you're using for sum? Hii inakaa ni kama ni umetumia ile symbol ifai kutumika. Okay, so hii symbol si correct. Haikai rectangle in a way. Ama then print sum. You see hapa kuna confusion. This one is supposed to be here. This symbol here, the processing symbol is supposed to be hapa juu. Na hii output inafaa kuwa chini. Hii ni output input. Na hii ni processing symbol. So hapo you're not haujashikanisha hapo. So yours is not correct. Who else? I think we have no other submission. So we have how many students? We have 1, 2, 3. Okay, let me repeat. 1, 2, 3, 4, 5. 5 students have submitted. Okay, that's good. That's good. So out of 8 students. So for the rest, tuta-assume hamkufanya. Yeah, so I think we've come to the end of the lesson. We're going to continue from there from the next lesson.